Alright guys, so in this video I wanted to talk about dividing polynomials by binomials. To understand this video, you probably need a good understanding of polynomials and binomials, as well as division. So if you don't know about those, you can go to Khan Academy, or if you have done or are doing them in school, you can go to your schoolwork. Okay. So to talk about how we can divide a polynomial by a binomial, I am going to use an example. So let's say we have x cubed minus x squared minus 4x plus 12. Okay. All right. And if we are going to divide this by x minus 2. Okay. So what's happening here is we have a polynomial and we are dividing it by a binomial, right? Just like I said in the intro. Okay. How are we going to do this? Well, what we're going to do is we're going to say, okay, we have x cubed. That's the first part of this polynomial, okay, that we're dividing. The second part of the polynomial is minus x squared, right? The third part is minus 4x. And the last part is 12. So all of these parts together are going to make up this polynomial, right? Okay. Now what we're going to do is we are going to subtract some y amount of x minus 2's. I'll explain why we're going to do this in a second, so that the full thing equals 0, okay? Now, how does this help us? Like, why would we do this? Well, if we're subtracting this polynomial by y times x minus 2, right, and it equals 0, that's basically the same thing as saying y times x minus 2 is equal to x cubed minus x squared minus 4x plus 12, okay? Because that's basically saying, right, because if they subtract each other and equal 0, that means that they're the same thing, right? Because anything subtract itself is equal to 0, okay? So if this subtract this equals 0, then they must be equal, okay? The same way, like 3 minus 3 equals 0, or 4 minus 4 equals 0, right? So anything subtracted by itself is going to equal 0. Okay. So we've established that that means that this y times x minus 2 is going to equal x cubed minus x squared minus 4x plus 12. So how does that help us? Well, if these two are equal, then that means that this y is going to be how many x minus 2's fit into this x cubed minus x squared minus 4x plus 12. Okay? Because if y times x minus 2 will equal this, that's basically saying how many x minus 2's will equal this, right? How many x minus 2's will fit into this? That's basically division, right? Finding out how many x minus 2's, in this case, fit into this polynomial. That's what we're doing here. So that's going to equal whatever y is. So just to say it again, whatever we have to multiply by this x minus 2 to equal this polynomial is going to be how many x minus 2's fit into this polynomial. So basically, if we find out what y is, then we can just use y as our answer. And this is just like long division. So in long division, we subtract from what we're dividing until we get either 0 or a remainder. So I just explained why we do what we do before, but it's just like long division. Yeah, except now we're applying it to polynomials. And I know I wrote a 0 there, but we can actually also get other numbers besides 0, other things besides 0, and those would be known as remainders. And we'll see how we deal with remainders later. But basically, we subtract some amount of x minus 2's until we get some number that we can't divide by x minus 2's anymore. And I'll talk about that later. Okay. Yeah. So, again, it's just like long division, except now we are applying it to polynomials. Also, we won't always end up with 0. We can also end up with a remainder, as we'll see, and we'll see how we deal with that remainder. Now, how are we going to find out what y is? How are we going to find out what y is? Well, first things first, we are going to basically get rid of this x cubed, okay? So we're going to find out what number times x minus 2, we have to subtract it, makes it so that this x cubed is gone, okay? So some w amount of x minus 2's is going to make it so that this x cubed is gone. That doesn't mean that the whole thing will be gone, it just means that the x cubed has to be gone, okay? And then we're going to get rid of this in a similar fashion, so we're going to subtract, let's say, p amount of x minus 2's, so that this goes away, okay? And then we're going to subtract q amount of x minus 2's to get so that this goes away, and then we're going to subtract some number of x minus 2's to get rid of this, right? And once we get rid of all of those different things, then we will have made it so that it equals 0, right? And if it equals 0, then we basically just would say, okay, we're going to add w plus p plus q plus the number that we multiplied to get rid of the 12. Let's just say it was y. Okay. I know I used y earlier in the example. This is a different y. I don't want to confuse you. This was the y that we had to multiply by x minus 2 to get rid of the 12, okay? Or to get rid of the constant number. It might not be 12, as we'll see, but I don't want to get into that too much. But basically, we have to subtract by w times x minus 2, and then we have to subtract p times x minus 2, and we have to subtract q times x minus 2, then we have to subtract y times x minus q to get rid of all of these different parts of the polynomial, okay? And then w plus p plus q plus y is going to equal our answer. It's going to be our answer, right? Because that's basically what we have to multiply by x minus 2 for it to equal this polynomial here, okay? Okay, so let's get started. We have to find out what w is if we have to subtract x minus 2 to get rid of this x cubed. Well, what is that saying? Well, that's just saying that w times x minus 2 has to have, or must have, an x cubed. Okay, it has to have an x cubed. If it doesn't have an x cubed, then what's the point in doing it? Because the point is to get rid of this x cubed. Now, it doesn't have to equal x cubed, okay? We don't have to subtract by x cubed, okay? We don't have to subtract x cubed. We can also have, it just has to have an x cubed inside it. If it has an x cubed inside it, that means that we're going to be subtracting an x cubed, like a x cubed. We're going to be subtracting x cubed, and that will get rid of this x cubed, okay? That's all we care about. We want to get rid of this x cubed. So there are two ways we can find out what w is, okay? We can say we want to turn this x into an x cubed, okay? We want to turn this into an x cubed. Or we can say we want to turn this -2 into an x cubed, okay? What I mean by that is we can make it so that w multiplies by x minus 2 so that it gets, it will basically factor out to wx minus 2w, right? Or let's just, yeah, minus 2w, right? We can make it so that the w makes it so that this thing is equal to x cubed, or that this thing is equal to x cubed, okay? But in this case, not both. So the w can make it so that this term becomes an x cubed, or that this term becomes an x cubed. I just want to make that really clear. We're basically saying w times x minus 2 must have an x cubed, right? And it's going to equal wx. I'm just factoring out the w. If that's unfamiliar, you can go to Khan Academy, or if you're doing this in school or have done this in school, then you can go to your schoolwork. But anyways, I won't be talking about that in detail. How we find out how we factor out the w. It's not the goal of this video. But anyways, so you can go to Khan Academy, or if you're doing this in school or have done this in school, you can go to your schoolwork. But anyways, it's going to equal wx minus 2w, okay? Now, if it must have an x cubed, that means that either this is going to be x cubed or this is going to be x cubed, right? We can make it so that w makes this x cubed, or it makes it so that this is x cubed, okay? Now, what we're going to find is that when we're multiplying some number so that it gets rid of one of these parts of the polynomial, we always want it to be the one with the variable with the higher exponent. So, for example, if we had x minus 3, we would want to make it so that, w times x minus 3, we would want to make it so that w makes the x cubed. We want to make it so that the w makes the x the thing that we want it to be, okay? So we're always going to pick the, so in this particular case, we would pick the x, okay? We always pick the thing with the higher exponent of variables. So I'll actually explain that in greater detail right now. X cubed, or actually let's just say x squared. X squared has an exponent on the variable of 2, right? Okay. X to the 4th has an exponent on the variable of 4. Regular x, we don't write it usually, but we have an exponent of 1. What about just 2, right? What about just 3? Well, 3 is actually equal to 3 times x to the 0. So the exponent on its variable is going to be 0, okay? So in this particular case, we have x minus 2, right? Right? This has an exponent of 1. This has an exponent of 0, right? Because negative 2 is equal to negative 2 times x to the 0, right? So it has the variable in it has an exponent of 0. And again, that might be confusing. You might not understand what that 0 means, but I won't be going into detail. So again, if there's ever anything in this video that doesn't make sense because I haven't explained it because it's not the goal of the video, of this particular video, then you can go to Khan Academy, or you can, if you've done this in school or are doing this in school, you can go to your schoolwork. But I will not be going into depth. I will not be explaining that in this case. But which one would we choose? We would pick the x, right? Because it has a higher exponent on the variable, right? So in this case, we are going to make it so that w times x equals x cubed, okay? And again, this might seem really complicated, but it's really not. I'm just writing it all out so that it makes intuitive sense. Yeah. Okay. So we want to make so that w times x equals x cubed. And by the way, I will actually, before we go into this, I'm just going to explain why we actually we pick the one with the higher exponent, right? Okay. If we made it so that w times x is equal to x cubed, so wx equals x cubed, right? Or we could make it so that w times 2, or sorry, times negative 2 equals x cubed, right? We could do either of those. But obviously, or maybe not so obviously, but they will make two different binomials depending on which path we take, right? Right? If we pick this route, okay, if we pick this route, in this case, right, what we're going to get is we are going to end up getting, I guess this is a bit of a spoiler for the video, but we'll do others where I don't spoil it, but this will result in a binomial that is x cubed minus 2x squared. Okay. Actually, no, I'm actually going to explain it. Explain what we just did. We need to make it so that w times x equals x cubed, right? That means that w must equal x squared, okay? Because x squared times x equals x cubed. We can just use algebra to figure that out. And if w equals x squared, right? That means that it's going to be x squared times, right? That's going to be x squared times x minus 2. And that is going to be x cubed minus 2x squared. Okay. Now, if we pick this route, we can use algebra and we can figure it out. I'm not going to actually do the algebra, but we can use algebra. And it turns out that it is going to be, that means that w is going to equal x cubed divided by 2, oh sorry, negative x cubed divided by 2. Now what is that going to mean? Well, that means that the full thing is going to end up being, the full binomial is going to end up being minus x to the 4th divided by 2 plus x cubed. Okay. Now the difference here, the problem with doing it this way, okay, is that this way we produce something with an even higher exponent, right? This x to the 4th has a higher exponent than x cubed than what we were getting rid of in the first place. So we were getting rid of this x cubed. So we knew that one of these terms needed to be converted into x cubed, right? One of them needed to be converted into x cubed, right? Either the x or the negative 2, right? The x or the negative 2, okay? If we choose the 2, then whatever we multiply the 2 by must equal x cubed, right? Now, if it multiplies by negative 2 to equal x cubed, then it's going to multiply by x, which has a higher exponent in the first place, to produce an even larger exponent term, okay? So if w multiplies by this negative 2 over here to equal x cubed, then this term, which has a higher exponent in the first place before it was even multiplied, it has a higher exponent than the negative 2, right? It is going to produce something with a higher exponent on the variable. Exponent. Wow. Okay, that's not very good writing, but this is going to produce something with a higher exponent because it had a higher exponent in the first place. So that's why we picked the one with the highest exponent to multiply by w to equal x cubed. Because that way we don't have any bigger terms than it, like we don't have any terms that are bigger than it, that multiply by that same w to produce something that is going to have an even higher degree than we started with. Okay? If we have a higher degree than what we started with, we've just created another problem for ourselves. And you might be thinking, well, why is it why is it a problem if we have a higher degree than we started with, and not a problem if we have a lower degree than what we started with? Because basically, okay, I'm just going to recap just to make things really, just to clarify. Basically, I'm saying that this negative 2, if we choose the negative 2 to multiply by w, so I'll write it over. Actually, I'll just make some space. Okay, over here. If we say that the negative 2 times w must equal x cubed, then the x times w is going to be something that has an even higher exponent. Higher exponent on the variable. Okay? Because this x had a higher exponent to begin with. Okay? So if it multiplies by the same thing, then it is going to have something that has a higher exponent than x cubed, right? Which was the result of negative 2 multiplying by w. Okay? That's if we do this. Okay? If we do this, we're going to result with something that has a higher exponent. Now, if we do this over here, we're going to get an x cubed, first of all, and then we're also going to get something with a lower exponent, right? In this case, it's negative 2x squared. We got something with a lower exponent than what we started with. Okay, so we know that we're going, we know that we're going to subtract this w times x minus 2. So we could either subtract this x cubed minus 2x squared, or we could subtract this negative x to the 4th plus x cubed, right? If we subtracted this negative x to the 4th divided by 2 plus x cubed, then we would end up with another polynomial, right? The polynomial would change, right? The x cubed would go away, but then we would end up with a x to the 4th divided by 2 in the polynomial, right? Or if we subtracted this, the x cubed would go away. The x cubed would go away, right? Because we're canceling out this x cubed and this x cubed. Would go away, and we would also be subtracting negative 2x squared. Okay, but that's okay because we have an x squared to get rid of anyways. Okay, so we have this 2x squared here, right? That we're changing the polynomial with, but that's okay because we have an x squared to get rid of anyways. So this negative 2x squared will just combine with this negative x squared over here, and it's all going to be okay because now we're just going to have another x squared term that we have to get rid of. And that x squared term we had to get rid of anyways. We already had to get rid of an x squared term. Okay? So it's just going to change our polynomial still, but at least that way we don't have an entirely new exponent to get rid of, an entirely new term. If we just subtract the negative 2x squared, then this negative 2x squared is going to combine with this negative x squared, and it's going to produce it's going to produce another x squared term, and then that x squared term we can get rid of. But we were going to get rid of an x squared term anyways. Okay? And you know what? Just because that might have sounded a little confusing, I'm just actually going to draw out the two scenarios. Okay. Okay. Let's say we subtract negative x to the 4th divided by 2 plus x cubed, right? That's the path. That's what we end up getting if we choose the w, make the w something that multiplies by negative 2 to equal x cubed, right? Okay, what is that going to end up getting? Well, that is going to change this polynomial to, well, let's say we're adding x to the fourth divided by 2, right? Negatives cancel. So we're going to have x to the fourth. Actually, I'll just write 1/2 in front of it. Okay, 1/2 x to the fourth. That's the same thing. Again, if any of this is confusing, because I'm not going to explain everything that I do, and I haven't explained all of the things that I do in this video yet, so if any of it is confusing, sorry, I haven't explained everything that I've done in this video in other videos yet. So if any of this is confusing, you can go to Khan Academy, or if you're doing this in school or have done this in school, you can go to your schoolwork. But anyways, we're going to end up getting 1/2 x to the fourth. Well, these x cubes are going to cancel, right? We're subtracting x cubed from this x cubed, right? So we're going to get rid of this x cubed. So then we're going to have minus x squared minus 4x plus 12, right? Okay, so what we basically just did is we created a whole new term, x to the fourth, right? But if we did it the other way, let's do it the other way. So I'll just draw that over here. We're going to subtract x cubed minus 2x squared, right? That's what we're subtracting, and that's the path. That's what we end up getting if we choose w to be something that we multiply by x to equal x cubed. And that is going to end up getting, well, the x cubes are going to cancel, right? This x cubed and this x cubed. So we're going to end up getting just nothing for the x cubes. We're going to get minus x squared, and we're subtracting this negative 2x squared, right? So subtracting negative 2x squared is the same thing as adding 2x squared. So we're going to have plus 2x squared minus 4x plus 12. Okay. Now notice how these two exponents are the same, right? Because basically, we made it so we chose the higher exponent term to multiply by w to equal x cubed, and that makes it so that the other term is going to definitely have a lower exponent than the term that we multiplied by w to equal x cubed. Sorry. So the other term that is produced is definitely going to have a lower exponent than this x cubed here, right? Because we chose the x to multiply by x. We chose the x to multiply by w to equal x cubed, not the negative 2. And if we chose the x, that means that the negative 2, or sorry, okay, so if we choose x times w equals x cubed, right? That means that negative 2 times w is going to be something that has a lower exponent, right? Because they started with this negative 2 started with a lower exponent than x in the first place, right? So a lower exponent. Okay. Right. And if it's going to have a lower exponent, then we know that there's going to be another exponent ahead of us that has that exponent, right? Right? Because we're starting with the highest exponent possible. So that means that next there's going to be a lower exponent. And there will be cases where that doesn't happen, but often it will be like that. But yeah, so basically what I'm trying to say is if we choose the x times w to equal x cubed, we're going to get something that has a lower exponent when we multiply w by negative 2, right? And that lower exponent term can combine with one of these terms that we haven't yet subtracted from. We haven't yet subtracted away. So it doesn't make our job any harder, right? Because we're basically just combining, we can just combine this 2x squared that we added, right, with this minus x squared. So we end up getting just x squared. So we were going to have to get rid of this x minus x squared before. Now we just get rid of an x squared. So it hasn't made our job any more difficult. It's just changed our job. It's just changed what we have to do. It hasn't made what we have to do any more difficult. Over here, we've added a whole new term. So it has made things more difficult because now we have to get rid of this term. And we're never going to finish if we just keep choosing that lower exponent term to multiply by w to equal x cubed. But over here, I hope you see, if we multiply the higher exponent term by w to equal x cubed, that way we just end up producing the excess, the extra term that we produce is going to be able to mix with, it's going to be able to combine with one of these terms over here. Okay? And that doesn't make our job any harder. Okay? So in this case, the negative 2x squared was able to combine with the minus x squared. Okay. Yeah. Just one more time, just to make things clear, because that might have been confusing. If we choose the lower degree term, right? So I'll write out. Okay. Let's say we have x minus 2, right? If we chose this to multiply by w to equal x cubed, then it works, because the other term is just going to end up producing a term that has a lower exponent, right? That's just going to end up being some number times x squared, right? In this case, it's going to be times w. It's going to equal some number. So some number, I guess, some number p times x squared, right? Because it has one less, or it's going to, okay. Yeah, so if we chose the x, sorry, let me restart. We chose the x multiplies by w to equal x cubed. That means that this negative 2 is going to multiply by w to produce something that has a lower exponent than x cubed. If that thing has a lower exponent than x cubed, then we've made progress, because we know that that lower exponent thing can just combine with one of these terms over here that is already in our polynomial to produce another term, right? So in this case, the extra term that was produced was 2x squared, and it combined with this minus x squared. And we just ended up getting x squared. Okay? So we ended up getting x squared minus 4x plus 12. That's the full thing. We didn't make our job any more difficult because we didn't add any new terms, right? Yeah. Okay, so sometimes it won't always cancel out like this, okay? But that doesn't mean that it won't work, right? So sometimes when we choose, even if we choose the bigger term to multiply by whatever we're multiplying it by, to equal whatever we want to get rid of. So in this case, we're multiplying x by w to equal x cubed. Even if we choose the term with the higher exponent, the extra term won't cancel out with one of the term, or it won't combine with one of the terms in our polynomial. But that still works out, whereas this does not, as we'll see. So let's actually use an example. You know what? I'll go into do an example of that after, just to prove that even if it doesn't combine, it will still work, and I'll show you that. But just know that we multiply by the higher exponent variable term right? So in this case, we chose x because it has an exponent variable of 1. Or sorry, a variable exponent. Its variable's exponent is 1. So it has a higher exponent than negative. It has a higher variable exponent than negative 2. So we multiply w by x to equal x cubed. We choose x to be the thing that w has to multiply by to equal x cubed. Okay. Whereas if we did the other one, we would end up producing an even larger exponent. And now we're just working backwards because now we have to go and cancel out with this x to the fourth. And if in that case, if again we choose the lower one, we're going to produce something with x to the fifth, some p times x to the fifth. And then we're going to keep going, and we're just going to get higher and higher exponent terms. So as we do that, so we're going to we're going to get rid of this x to the fourth, sure, but then we're going to add something to this polynomial, p x to the fifth, right? Okay, some number times x to the fifth. I don't know what it is, but you will in this case. So that doesn't work when we're dividing polynomials by binomials. So just again, we always multiply by the term with the higher exponent. We choose the term with the higher exponent to be the thing that w in this case has to multiply by to equal whatever we want to get rid of. So in this case, we wanted to get rid of the x cubed. So we said w multiplies by x to equal x cubed, right? And then we found out our w that way. If we chose the negative 2 to multiply by w to equal x cubed, then we're going to produce a term that has an even higher term than what we were trying to get rid of. And we've created a problem for ourselves. And then if we do that again, if we choose the one with the lower exponent again, the lower exponent on the variable again, then we're going to get something with an even higher exponent, and a higher exponent if we do that again, and then a higher exponent. So it just doesn't work when we do that. So we always pick the term with the higher exponent on the variable. Okay. So anyways, after all of that, we have concluded, right? We've concluded that we're going to get, let's get rid of all of this. Okay. We're subtracting w times x minus 2, right? Which one are we going to choose to multiply by w to equal x cubed? We're going to choose this x to multiply by w to equal x cubed, right? So that just means that w times x equals x cubed, right? We can find out what w is using algebra. So we divide both sides by x. We end up getting w is equal to x squared, right? So that means that, in other words, if w is equal to x squared, we're subtracting x squared times x minus 2. Okay? So we're subtracting x cubed minus 2x squared. Okay. Right? Or plus 2x squared. Sorry. Forgot to write that. Okay, so we're subtracting x cubed minus 2x squared. The negative carries in, so negative x cubed, that's equal to negative x cubed plus 2x squared. Okay. Okay. So the x cubed is going to cancel out with this x cubed, right? Now we have the 2x squared over here. It's 2x squared over here that we're still adding, right? So we're adding this 2x squared. So what are we going to get? We're going to end up getting no x cubed, right? Because the x cubes cancel out. We're going to get minus x squared plus 2x squared minus 4x plus 12. Okay, and that's the same thing. That's equal to just x squared, because these combine to form just x squared minus 4x plus 12. Okay. So far, we need to keep track of this. So far, we have subtracted x squared x minus 2's, right? We subtracted that many x minus 2's to get this new polynomial, right? Now we need to continue by getting rid of this x squared, okay? Okay. So I'm going to get rid of this, right? We don't need that anymore. Now what we have is we have a new polynomial. We have x squared minus 4x and 12, right? Or actually, I'm going to keep that just so that we remember where we started, right? Okay, but our new polynomial, right, is going to be x squared minus 4x and then 12, right? Okay. So actually, I'm just going to box this off. Okay, so just to make it clear, we're not dealing with this. We are dealing with this right now, okay? Okay, now what we need to do is we need to get rid of this highest degree term from the polynomial. So before we got rid of the x cubed because it was the highest exponent on the variable, right? Now we get rid of this because it's the highest exponent on the variable now, right? Because we got rid of the x cubed. So now we have to get rid of the x squared. Okay. We know some number, right? I'll just use w again. It's going to be a different number this time, but minus w times x. So we're subtracting w times x minus 2, right? And we know that w times x minus 2 must have an x squared in it, right? Which one are we going to choose to multiply by w to equal x squared? We're going to choose the x, right? Because it has a higher exponent on the variable. So w times x is going to equal x squared. If we divide both sides by x, right, just use algebra like we did before. Not exactly, yeah, so we're just going to use algebra. We get w is going to equal x. Okay. So we know that w is x. So how many x minus 2's are we going to subtract? We're going to subtract x amount of x minus 2. So instead of w, I'm just going to write x times x minus 2. Right? Okay. All right. That's the same thing as subtracting x squared minus 2x, right? That's the same thing as subtracting x squared and then adding 2x, right? Because the negative carries in. Okay, so let's get rid of these. Don't want to confuse you. Okay. Okay. So we're getting rid of an x squared, right? So these x squareds cancel, right? Okay. Now this 2x, so this 2x will become part of the polynomial now, right? So we have minus 4x plus 2x plus 12, right? That's our new polynomial. And this simplifies to minus 2x plus 12. Okay. So we have minus 2x plus 12. That's our new polynomial. So we're going to have, let's get rid of this. So we have minus 2x. That's our first part, right? Or sort of part. Okay, and then we have plus 12. Right, so that's our polynomial now, okay? So I'll box this off now because we're not dealing with this anymore, right? So what are we going to get rid of now? We're going to get rid of the minus 2x now, right? Because it's the highest exponent, it has the highest exponent on the variable. So we always get rid of the one with the variable with the highest exponent. And in this case, it is minus 2x. So we're subtracting some w, right? Some w amount of x minus 2. And this seems like a really long process, but that's just because I'm drawing it all out with these boxes, right? Like with these like different parts. I'm going to do an example where we just do it really quickly without going through all of the steps, right? And like, you know, drawing it out and stuff. Okay. So we're going to subtract w times x minus 2. We know w times x, right, must be equal to negative 2x, right? Because we're getting rid of this negative 2x, right? So we can use algebra, divide both sides by x, and we get w is going to equal negative 2. Okay, so that means that we're going to be subtracting 2, and what are we subtracting? We're subtracting negative 2, right, times x minus 2. Subtracting negative 2 times x minus 2. Right? Okay. So w is negative 2, so we're subtracting w times x minus 2, which is, we're subtracting negative 2 times x minus 2. Okay, so that's the same thing as subtracting negative 2x plus 2. Plus 4. Okay. So the negative carries in, so we get, and again, if any of this doesn't make sense, you can go to Khan Academy, or if you have done or are doing this in school, you can go look at your schoolwork. But I won't be going into detail about all of the things that I'm doing, like the algebra and other stuff. So we have 2x minus 4. Okay. Now this negative 2x is going to cancel out with this 2x, right? And now what we're going to have is 12 minus 4, right? That's our polynomial, I guess you could say. So we just end up getting 8, right? That is going to be our I guess you could call it our polynomial, even though it's just a number. It's not really a polynomial though. So we have this number 8, okay? So now I'm not going to, well, I'm not actually going to try and get rid of this 8, right? Because w, so if we subtract w times x minus 2, w times x, it's not going to get rid, any w times x is not going to get rid of this 8. So basically what we've done, I forgot to record all of the things that Okay, so sorry. I just realized I forgot to record. Remember when I said we need to record what we are multiplying by the by x minus 2 to take things away? So I just forgot to record those, but I just recorded them. So basically, we multiplied by x squared to get rid of the x cubed. We multiplied by x to get rid of this x squared. Then we multiplied by negative 2 to get rid of this negative 2x. Okay. And what we have left is this 8, after we've subtracted all of those x squareds, okay? So, our answer is going to be, and I'll explain this in a second, but it's going to be x squared plus x minus 2. Okay? Plus 8 divided by x minus 2. Okay, so what did I just do? Okay, well, I basically just took all of these, right? And I said, okay, x squared plus x minus 2 is going to be how many times x minus 2 goes into this polynomial expression, right? The polynomial expression that we started with and we wanted to divide by x minus 2. Now there's a problem. We ended with 8. We did not end with 0 as we had hoped. So what we have here is a remainder. We have a remainder of 8 because we couldn't get rid of it by subtracting a bunch of x minus 2's. So what we basically write is our answer is x squared plus x minus 2. That's what we multiplied by the x minus 2's to get rid of all of these different things, right? Plus 8 divided by x minus 2, plus our remainder divided by x minus 2. So again, we had a remainder of 8, right? We had an 8 left over that we couldn't divide by x minus 2, right? Or we couldn't, we couldn't divide it by x minus 2. So we're just going to write it as 8 divided by x minus 2, okay? So that's going to be our answer. X squared plus x minus 2 plus 8 divided by x minus 2. Okay? So this times x is going to equal, is going to be basically what we had to multiply by x minus 2 so that we could subtract that. So we subtracted, basically what we did is we subtracted x squared plus x minus 2, right? This is what we subtracted. Oh. We subtracted this. We subtracted this times x minus 2, right? We subtracted this whole thing from this polynomial over here to get 8. And our answer was, so we ended up getting an 8 at the end. So we had x cubed minus x squared minus 4x minus 4x plus 12. And we subtracted x squared plus x minus 2 times x minus 2, right? So basically what I did was I recorded all of the different things that we multiplied by x minus 2 to get rid of like the x cubed, the x squared, and so on. Okay, that's what we subtracted from it, and we ended up getting 8, right? That's what happened basically. So we found out that our answer is going to be x squared plus x minus 2, but there's a remainder of 8, right? Because we couldn't get rid of 8, right? We couldn't get rid of that number, okay? So basically what we have to do is we have to say, okay, our answer was x squared plus x minus 2, okay? And that's getting rid of most of it, right? But we also have an 8 that we couldn't, we also have an 8 here, so we have, and we're dividing it by x minus 2. So we're dividing the remainder, this is really just the remainder, right? By x minus 2. And we'll see that correlation later in a second. Okay. So now let's do that example I was talking about where they don't cancel and you pick the larger term to multiply by w to equal whatever you want to get rid of. Okay. So let's just get rid of all of this. Okay. So let's say we have x cubed plus x minus 1, okay? Now, we're dividing it, and we're dividing it by x plus 1, okay? And actually, I'm just going to write it out like this. So if you know from long division, this is how we write it out when we are dividing using long division. So I'm just going to write it out like this. So x cubed plus x minus 1, and we have x plus 1. Okay? Okay. So we need to subtracting some amount of some w times x plus 1, right? To get rid of this x cubed, okay? We know it's going to be x that we're multiplying w by to get x cubed, right? So w x equals x cubed, okay? And that means if we use algebra, we get w equals x squared we get w equals x squared okay. So if w equals x squared, instead of, so I just wrote minus w times x plus 1 just to show that we're subtracting by some number. But really what we would do, just to speed things up a bit, we would write it out just like this. We would say minus x squared times, actually, yeah. I'll show you how we would write it out. This is not how, but I'll show you. Times x plus 1. Okay. Okay, so that's the same thing as subtracting. So we would record x squared, right? X squared is the w. So we're subtracting x times, we're subtracting x cubed, basically. And then we're also subtracting x squared. Okay, now what do we end up getting when this happens? Well, we know the x cubes cancel, right? Now this x squared and this x aren't going to cancel, right? So we're going to end up getting minus x squared plus x minus 1, okay? But the thing is, this is something that we can solve, right? Because as we slowly got, basically we did make progress in that last one. Even if we still have the same number of terms, we still made progress because we managed to get a lower exponent term, okay? And in doing that, we basically made progress because now if we subtract w times x plus 1 to get rid of this x squared, right? Let's try it. I'm just going to say wx has to equal minus x squared, so it's minus x times x plus 1. Okay, so what we're going to end up getting is x times x plus 1. So we're going to end up getting x squared plus x, okay? Now what happens there? Well, the x squareds cancel, right? Now this x is going to combine with this, right? So basically we did make progress because we managed to get a lower exponent. And in getting a lower exponent on our variable, we got even closer to getting to this last term, right? We got even closer to getting to this last term. As we decrease our exponent, the exponent of the term that we're trying to get rid of, we get closer to getting to the last term, which is a constant, usually, or often it is a constant, or just it's a low term. And in any case, doing that will end up getting us to a lower term. So, yeah. So even though at first it didn't cancel, we did make progress because we ended up getting the highest variable exponent in our polynomial that we were dividing by, or that we were dividing, decreased. It decreased. So we ended up getting closer to that end, the end of the problem. Okay. Okay. So now I just want to show you guys how. Actually, just to make it really clear, at first we had, just to make it really clear why we're getting closer when we do that. So we have x cubed plus x minus 1, right, at first. Then I think what we ended up getting was minus x squared plus x minus 1, right? Now this is close. This is closer to a finished product. Sorry, to a finished problem, I guess. Almost, it's than this, right? Because basically the goal is to keep decreasing the exponent of the term that we're getting rid of until it gets to a real and until we finish the problem, right? So first we subtracted. First we had to get rid of an x cubed, but now we only have to get rid of an x squared. And after that x squared, we're going to have. It means that we're going to be moving on to this x. So as long as the exponent is decreasing, we're getting closer to finishing the problem. So we do make progress as long as we pick the largest term to multiply by w. That's just the variable that I'm using to explain. So as long as we pick the term with the largest exponent for the variable to multiply by w to equal whatever we need to get rid of. Okay. So basically, just what we have to do. Yeah. So as long as we follow that process, yeah, it will result in progress being made when we're doing our problems. But if we do it the other way, then we're just going to keep getting a higher and higher exponent, and we're never going to finish the problem if we keep doing it like that. Okay. So now let's talk about it. Talk about a problem when. Well, let's talk about just doing a problem quickly, right? Doing it all like, yeah. And it actually looks a lot like long division. It looks similar to long division, okay? So let's say we have 3x squared minus x squared plus 2x plus 4. And we are dividing it. I'll just draw it out like this. We're dividing it by x plus 4. So you might notice I'm doing it in the long division way, right? And you'll see what I do. So first, we know we have to multiply some w times x plus 4 to get rid of this 3x squared, okay? Well, what do we need to multiply by x to equal 3x squared, right? Well, 3x. So we would write that 3x, whatever w is in that case, we would write it up here, right? And then we would subtract this 3x times x plus 4, right? Okay, we would get rid of it. So what happens when we do that? Well, we're basically subtracting 3x squared minus 12x, right? That's it. Yep. Oh, shoot. Okay. Sorry. I just made a mistake when I was writing out this question. Oops. Okay. Sorry. What I meant was 3x cubed. Okay. 3x cubed minus x squared plus 2x plus 4, and we're dividing it by x plus 4. Okay. So what do we need to multiply by x to get 3x cubed? Well, 3x squared. So we have to multiply x by 3x squared to get 3x cubed. So now what we're going to subtract is 3x squared. Sorry, I don't mean to confuse you. I just made a mistake in writing out the question. That's all that happened. So we're going to subtract 3x squared times x plus 4. We basically just said x plus 4 times some number equals 3x, turns into a number that is able to get rid of this 3x cubed. So we have to find out x times what number equals 3x cubed, right? Just like before. And that number is 3x squared, right? And you can use algebra to figure that out on your own, or if you can do it in your head, yeah. But then we would subtract 3x squared. Actually, I'll just do that one example. So that would mean x times some w must equal 3x cubed. So I'm just going to show you how to do it. Then we would divide both sides by x. Divide both sides by x. Okay. And we get w is equal to 3x squared. Okay, so what we have to multiply by it is 3x squared. So we write the 3x squared up here, okay, just like in long division, except usually before we were doing it with numbers, right? Now we're doing it with polynomials and binomials, but okay. So we subtract 3x squared times x plus 4. That's the same thing as subtracting 3x cubed and then subtracting 12x squared. Okay. Okay, and then we cancel these, right? So it looks similar to long division, right? And then we would say minus x squared minus 12x squared. What is that? Well, that is going to be minus 13x squared, right? Okay. And then we take down these two. So it's really similar to, we're really seeing similarities in long division. And I won't be going into what long division is because I'm just assuming that you know long division. If you don't, you can go to Khan Academy, or also if you've done it in school or are doing it in school, you can look at your schoolwork. But anyways, I'm not going to talk about what long division is with regular numbers. But anyways, we would get this, and then, well, we would find out what we have to multiply by x plus 4 to get minus 13x squared, right? And I'm pretty sure that is minus 13x, because x times what do we have to multiply by x to equal minus 13x squared? Well, we have to multiply by minus 13x. So we subtract minus 13x. So we're subtracting w times minus 13x. Don't get confused with the negative signs. W itself is minus 13x, and we're subtracting w times x plus 4. So like this. And you don't have to write this step. Well, you might have to. It depends on what your teacher wants, or what you want to do, I guess. You don't need to, I guess, whatever you prefer, or whatever you need to do. But anyways, I'm just writing it out to, to show it. So it's 13x times x plus 4, and that is the same thing as 13x squared. And by the way, now we're adding it, right? Notice how the negative signs canceled out. So now we got 13x squared plus, 13 times 4. Okay. Okay. yeah, so now these 13x squareds cancel out, right? So now we say 2x plus 52x. What is that? It's 54x. And then take this 4, pull it down, right? So this is just the process. If you want, if it's more intuitive for you to draw them out as parts and stuff, sure. It might take a bit longer though, so it might be useful to know this as well. But anyways, now we want to get rid of this 54x, right? Because it has the highest exponent for the variable. So what times x equals 54x? 54. Add 54 over here. Okay. So 54, we're subtracting 54. Subtracting 54 times x plus 4, right? That's the same thing as subtracting 54x and then subtracting this. Let's use the calculator. Then we know that these cancel. What is 4 minus 216? It's minus 212. And yeah. Okay. And once we get to this constant, and it's a binomial, we cannot actually divide this any further. So our answer is 3x squared, right? Whatever we wrote on the top, right? Because that's basically how we recorded it. So 3x squared minus 13x plus 54 minus 212 divided by x plus 4. Okay? So we take a remainder and we divide it by our what we were dividing it by. Okay? So yeah. Because we still have that that part that we haven't divided by x plus 4 yet. So we basically represent the whole thing as 212 divided by x plus 4. We just haven't simplified it, but it's right here, right? We just haven't simplified it. Okay? Yeah. So we were able to get rid of most of it, right? Except we ended up with a negative 212. Okay. All right, and just to make it really clear why we do this with the remainder, I'm just going to say we started with 3x cubed minus x squared plus 2x plus 2x, right? And the whole thing was divided by x plus 4. And we ended up with three x squared minus 13x plus 54 minus 212 divided by x plus 4. Okay. So basically what we were doing when we were subtracting all of these x plus 4s away, right? Basically, we were converting some of this into an answer, like into an answered part, right? So, for example, this 3x cubed here, we know that x plus 4 times minus 3x squared will make this 3x cubed go away, okay? So that's where we got this 3x squared. There are going to be 3x squared x plus 4s inside this polynomial, right? That's not all the x plus 4s there are going to be, but there are going to be 3x squared x plus 4s. Now there are also going to be minus 13x x plus 4s inside this polynomial. Okay, so we have that. And there are also going to be 5x plus 4s inside this polynomial, right? And we got all of that by subtracting different amounts of x plus 4s from this to get rid of its different parts, right? Now we ended up with a number, right? We ended up with this number here, okay? And that's still part of the polynomial, okay? So there are this many x plus 4s inside this polynomial, right? Right? But there are also going to be minus 212 divided by x plus 4 x plus 4s, right? So we ended up finding out a certain amount of x plus 4s that were inside this polynomial, but we didn't find out all of the x plus 4s that were in the polynomial, because there's still this minus 212 divided by x plus 4, right? So we can't really re-express this minus 212 divided by x plus 4. It basically represents how many more x plus 4s there are inside this polynomial. Right, so this beginning polynomial. Oh, I just realized something. I forgot to write plus 4. Whoops. Sorry. My bad. But anyways, I don't think it was that important for that what I was just talking about. But basically, they're going to be, what I was saying was that we ended up with a remainder. So we ended up finding out how many x plus 4s were inside part of this polynomial. But part of the polynomial, we couldn't find out how many x plus 4s were inside that, okay? So we just basically expressed that with this minus 212 x plus 4 divided by x plus 4, okay? Yeah. So again, what we did was we had all of these terms inside our polynomial expression. We found out how many x plus 4s there were inside it, right? But we didn't find out how many x plus 4s there were total inside it. We only found out some of the x plus 4s that were inside it. Part of the number of x plus 4s that are inside it. So what we have to do, because there's a remainder, is we have to say minus 212 divided by x plus 4, okay? Because that's basically saying how many x plus 4s are in minus 212, right? Right? So just have to make sure. So it's minus 212 divided by x plus 4. Because we found out how many x plus 4s were in the rest of the polynomial, we just have this remainder here. And basically, we have to find out, that looks like an equal sign, okay. So we found out how many x plus 4s were in this part of the polynomial, right? But we did not find out how many x plus 4s were inside this negative 212. So our answer is going to be what we found out, right? Minus 212 divided by x plus 4. Because minus 212 divided by x plus 4 is basically saying how many x plus 4s are inside minus 212. And because we can't solve that, we just have to write minus 212 divided by x plus 4 to represent whatever that number is, okay? Whatever that is. All right, so that's why we do what we do with the remainder. So again, we can find out when we have a remainder by basically if the largest term, in this case it's x, if the term with the highest exponent in the variable of what we're dividing by, or what we're dividing with, what we're dividing by is less than the highest, the term with the is less than the exponent in the term with the highest exponent for the variable. Or sorry, greater than, if the exponent, if the highest exponent for the variable, for the terms in what we're dividing by, so in this case it would be x, right? And it's 1, there's an exponent of 1 for the x, is higher than whatever we have left, is higher than the exponent for the variable of the highest exponent variable, right? So like in this case we have 0, right? That's the highest possible one. Then we can't divide any further, so that is going to be our remainder. Whereas if we had this like 54x plus 4 over here, the x, the highest exponent in a term is 1, right? So this is also 1, so it's not greater than this, right? So we can still divide further. But once we reach a certain point where it is actually greater than the highest exponent in whatever we have left, then that is our remainder. So in this case, this is our remainder because we can't divide any further. And we know that because the highest exponent for the variables in x plus 4 is 1, and that is higher than 0, which is the highest exponent in minus 212, which is what we had left. Okay, so that pretty much concludes this video. Thank you.